Hey folks, so in this video we're going to continue our discussion of the low-level features that the operating system needs to support. In the last video we talked about the basic services, right? So low-level things that we need to provide so we can have programs running on a computer that a user can interact with. And this is right, basically things right that the user kind of is going to sort of deal with or be influenced by, all the time. Now, on the other side of things, right, in addition to these kind of basic utilities that are offered, we have basically the features that are necessary for the operation of an operating system, right? So these are more behind-the-scenes things, right, that maybe are not, visible to the user right on a day-to-day basis, right? These are things that kind of just, magically happen. So I have three examples here, right? So first one, resource allocation. So the idea here, right, is that you as a user are using your computer. I, for example, using a computer, I have PowerPoint open. But also open is, I believe, Windows Explorer, and then OBS for recording, and maybe some other recording thing as well, I forget. So I got like 5 programs open immediately. Why is this important? It's important because the computer does not have 5 CPUs, right? So I can't actually run them all, on a different CPU, right? And probably, right, my computer also doesn't have an infinite amount of memory, so I may not, I have to basically, divide up my memory among my different programs. So what am I getting at here? I'm getting at the following. Computers have a fixed number of resources. However, there isn't a fixed number of programs running. So there has to be some sort of mechanism to allocate that fixed amount of resources to the different programs that are actually running right now, right? So I have Excel, I have PowerPoint open. PowerPoint is getting most of the resources because it's what's active, right? There are other things in the background, like for example, the Windows Explorer thing, but it's probably not getting a lot of time on the CPU. It's probably not getting a lot of memory because it's not important to me right now, okay? And behind the scenes, right, basically I have to have an operating system that can make that determination. It can look and see what's running. It can decide, this is how much memory I'm going to give you. This is how much CPU time I'm going to give you, right? And it needs to basically divide it up so that everybody gets a chance to do some stuff. And there's some prioritization perhaps based on what's actually being used, right? PowerPoint's up right now. Want to give it the most resources, okay? So this is kind of something behind the scenes that your operating system needs to support, right? Is how do I allocate resources between the different running programs? Note the resource allocation can kind of have 2 forms here, and I've kind of highlighted here on the slide. One is exclusive, the other is non-exclusive. So, for example, using a CPU is exclusive. If I have a physical CPU, one die, I can only have one program running on there at a time. Okay, I can't share a CPU. I can't directly share a CPU, right? Because only one thing is allowed to run at a time. I can switch between things, but I can't, really run 2 things in parallel. Right? I need to have a separate die with a separate CPU in order to have 2 things running at the same time, right? I can't magically feed 2 programs on the same CPU without, at the same time, right? I have basically one resource, right, that's not shareable. Versus other things like, for example, so like right now I'm wearing a microphone because I'm recording in a studio. That's a non-exclusive resource. So I could have different programs that are both listening to the same microphone at the same time, right? Because neither of them, right, are going to break anything. If I have multiple things listening, right? So I have, Camtasia is recording, OBS is recording, whatever is recording. All those things can happen at the same time. They can happen in parallel, right? So I have to allocate that microphone to the different programs, but I don't have to be exclusive about it because they can actually all use it at the same time, right? They're all just taking input. They're all just reading that thing. They're all just hearing the same thing, right? So it's the same thing as a bunch of people sitting in the classroom. Everybody can sit in the classroom and hear the same stuff being spoken because I don't require, exclusive access, right? Maybe office hours are exclusive, but sitting in class, everybody can kind of get a hold of that resource called listen to the professor at the same time, right? So those are the 2 basic types of resources. All right, so accounting. Okay, so accounting is, this is something maybe that'll be a little bit unfamiliar to some of you guys, depending on if you've only used kind of home computers. Accounting basically has to do with the fact, or the idea, that you'll have multiple users on a system, right? And I mean, for me, right at home, right, I'm the only user of a system, so on my home computer, right, or my laptop or my work machine. So it's not really important to me. I just basically go and I log in under my name, and I can do whatever I want, right? I have full rights, I have full resources, blah, 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 blah. And probably that's what a lot of you are used to. But then we have other environments, right? We have maybe environments that are more business related or school related, where I have shared computers. So for example, I'm on a machine right now recording that has multiple user accounts, right? So there's an account for me, there is an account for somebody else who does recording, a couple other people do recording, there's an account for IT, there's an account for media. All of these different accounts are set up on this machine. And these accounts actually can be alive at the same time, right? So I'm logged in as I think one of the guys that works here. But I could, right, basically switch and I could log under my ASU account and I could do my stuff, right? So I have this notion basically of a shared system. So this is something you may or may not have encountered. There's also, for example, things like servers you log into remotely. Like maybe you guys, I don't know if you guys have heard of it, but there's something called ASU General. Basically, there's a server out there, a Linux server, or Unix, Unix-like server that ASU maintains. And you can go log in on there, and it's actually a server that anybody can log into, right? So it's one physical computer somewhere, right? But different people can log in and do stuff at the same time. And so we have to basically have this idea, right, of these shared systems where I need to keep an account for everybody, right? So I need to know, for example, who is logged in, who is doing stuff, how much memory are they using, how much hard drive space are they using, how much CPU are they using. I need to know all these things so I can balance it, right? I don't want, on a shared system, one person to log in and all of a sudden monopolize all the disk space or all the CPU, right? Then the experience that other people are having will degrade, and that's not what I want, right? I want everybody basically to share this resource at the same time, right? And so to enable that, right, we have to have this idea of accounting. Now, accounting is something that if you don't set it up right, you can have a lot of problems. Now, one thing that I always remember, and this is actually going back to when I was a student, is that many years ago, right, I took a class basically on supercomputers, right? Basically how to do programming on supercomputers, or they use the term high-performance computers, right? HPC is kind of the name of that area. They don't use supercomputer all that much. And so way back then, right, I took this class, and as part of it, they gave us accounts on the supercomputer, right? So here at ASU, we have ASU Saguaro. That's the name of our supercomputer, and you should be able to access it, right? Even if whether you're ground or online, right? You may be able to find. You have to go and look for their website, right? There's ways to get access to it. But way back when I was a student, right? I took a class on it, and so naturally they gave us all accounts on it. So this is fine, right? This makes sense because, like, well, I want these people to be able to use this computer. I need to give them accounts on it. The thing is, though, when they gave us accounts, what they did not do is they did not give us any restrictions, right? So they didn't give us any restrictions for how much hard drive space or how much CPU time we could use. You can probably imagine what ended up happening. Basically, right, is that resource, right, that supercomputer, right, is shared among not just students, but also researchers. In fact, it's primarily for researchers, right? So people doing things like, for example, fluid dynamics, right, or protein folding. People that have very computationally heavy tasks are using this computer, right? And they're using it in research, right? And so they're, the typical users. Then along come us, right? We're students, we're practicing with stuff, right? We're learning how to program all that stuff for the first time. And so what started to happen, right, is that the researchers, right, they're used to, that this system being available and they can just use it whenever they want. Well, all of a sudden you have us as students, the day before something's due, we'd all go and start working on the homework. You're not supposed to do that, but that's what we did. And so all of a sudden, the researchers which had work to do found out that they basically could not use the computer anymore because instead of having this supercomputer available for them, well, all the students basically had requested all the resources that are out there, right? So instead of saying, oh, the students in this class can only use 10% of this compute cluster, we were basically allowed to request everything, right? And so you could go in there and you could say, oh, you know what? Give me 1,000 CPU cores, right? And the cluster probably only had like 5,000 or something like that, right? So I as a student could go and reserve 1/5 of that compute power, right? And all of a sudden that's all reserved for me, and other people that actually have research tasks can actually use it, right? And so this ended up being a big problem. There were kind of several points during the early semester, right, where basically the students would go and reserve everything, right? So we'd reserve all the CPU cores, all the time on it, right? And the people who had research to do couldn't actually get anything done. So this is kind of a big problem, right? And so what ended up happening, right, is they, of course, limited our accounts, right? So we basically got limited. It's like, okay, now you can only request 100 CPUs. You can only request them for 2 hours at a time, right? And so that kind of mitigated the problem because all of a sudden us as students, right, we couldn't, on our limited account, our accounts were now limited, right? So we couldn't just go and request the entire supercomputer ourselves, right? Which is what people were doing. So that kind of is a very kind of a critical example or an important example of why you want to do accounting properly, right? You want to be able to do your user identification, you want to allocate resources to users, because otherwise you run that chance of these users basically overwhelming your system so that other users, right, aren't able to do what they want to do, right? It's not good that us as students, right, we basically reserved all the resources, and the researchers, right, which have deadlines, important research studies to do, right, couldn't actually get their work done, right? That's not a good thing. So you want to basically have your accounting set up in the right way to prevent those types of issues. All right, last thing here, protection and security. So protection and security. This is right, maybe, well, this is stuff kind of we're all aware of these days, right? We always hear, right, the terms, firewall, antivirus, right? The idea, right, is that your system, right, maybe somebody may want to break your system, right, for one reason or another. Maybe they want information on it. Maybe they want to use it for something else, right? You typically need to have your operating system basically be on guard for those things, right? It should monitor and make sure that somebody who's not allowed to use the system isn't trying to use it, right? Or that a program isn't trying to do something that's not supposed to. It's not trying to break your computer or crash it or format the hard drive or something else, right? So we need to have kind of different mechanisms behind the scenes basically to watch for those things, right? To make sure that our computer isn't going to basically be waylaid by something else, right? So these are kind of very typical tasks. Okay. So I actually want to show you guys a little bit of an animated GIF, and I tried hunting down the source, but it was too hard to find, so I have basically unknown. But I want to give you guys an idea of maybe security gone wrong. So let's take a look at this GIF. So this is an old operating system. You can see here we're trying to log in. We try to log in, we don't have the password, we don't know what to do, right? We failed at it, right? And maybe we're an unauthorized user. So what are we doing? Notice here we're clicking through and we're starting to look at property menus. What's going on? Just watch it. Click through, click through, click through. Somehow we're in help. Again, our problem was we couldn't log into the system. Another option in help. But all of a sudden we see the files on the desktop, which is interesting because we haven't even logged in. And then going to our computer, trying to view, hey, look at what happened. We just saw our desktop there at the very end. So let me see if I can replay that video and we can go through that one more time. So again, right, we don't have a password. Clicking through, clicking through. What's happening here, right, is that this is actually an operating system that's supposed to have some sort of support, right, for basically, preventing unauthorized access, right? And so we saw there, right, initially, right, we're like, oh, we don't have a password, how do we get in? This is actually a little bit of a loophole, right? So in Windows 95, which is what we're showing here, you can actually go through these different steps, right? We're kind of, maneuvering through all these different windows. And if we go through, right, there's actually basically this exploit where it's like, well, we can actually get to desktop, we can actually do things without logging in, right? And so here, right, you can kind of see this is how you're kind of getting more information, right? You start out by being basically at that login screen, right? You go into help, you went to different help pages, and all of a sudden you got to see the desktop's contents, right? So this is kind of an example, right, of security gone wrong, right? We don't want to have this, right? We don't want to have an operating system where we can just log in, right, even if we don't have the right credentials, right? We want to be able to restrict access, right, so the only people that should do things are actually doing them, right? All right, so this is just kind of a neat little example. If you go to the slide deck, you should be able to see the animation as well, right? This is kind of a typical example of security gone wrong. All right, so that's all I got for you guys in this video, right? So hopefully this gives you a little bit of a sense, right, of kind of behind the scenes things that needs to happen, right? So resource allocation, accounting, security protection, right? These are the things that operating system needs to support in order to provide that user experience, right? The user's not going to necessarily see these things, but in order to have a good experience, right? In order to have fast programs, in order to have things that don't lock you out, you need to support these features as well.